Let's take a look at problem number 20 in chapter 7. So here we're looking at a sampling distribution. And just like in the last chapter, we're kind of assuming that a sample distribution or a sample probability distribution um, follows kind of a normal curve. So we're going to use some of the same tools we used in, in chapter 6. So let's look at problem number 20. So we have to understand the difference between a population and a sample. In this particular case, we're looking at people who are unemployed, and we're reported or we're assuming by previous sampling that the average number of weeks an individual is unemployed is 17.5. So that's the population mean. So we're just going to, this is a good way to set up these kind of problems. We'll just say our population mean is 17.5. That's given to us. And it says the standard deviation for the population is 4 weeks. So one standard deviation from the mean is 4. Okay? Now it wants to know, it says show the sampling distribution of X bar. So it wants the, so basically what it wants is it wants the expected X bar. So if we're going to take a sample of this population, we would expect the X bar or the sample mean to be close to the population mean. Okay, so we'll say that 17.5 is the expected X bar of our sample. Now I want to know what the sample standard deviation is. And before I can calculate that, I need to know what the sample size is. And it tells us that the sample size is 50. So I'm going to put that right here. Sample size is 50. So I can, if I know that the sample size is 50 and I know that the population standard deviation is 4, I can calculate the sample standard deviation, or what your book calls the standard error. And to do that, it's just the population standard deviation divided by the square root of the sample size, which is 50 in this case. I don't know why this is blocking this out, but it's C8. So I'll just type in there C8, which gives me that 50. Okay? So you can see that my sample standard deviation is much smaller than my population standard deviation. I have to know this. I have to know the sample size in order to calculate that. You can see if I used a bigger sample, so for instance I'll double the size of the sample. If I'll make the sample 100, then that will make the sample standard deviation smaller. So basically what that tells you is the larger the sample, the more, the higher the probability that it's close to the population mean. So anyway, for our purposes, it's 50. All right, now the problem wants to know in part B, this is basically part A. So this, I'll just color these yellow, this and this, that's the answer to part A. Part B wants to know what is the probability that a random sample of 50 unemployed individuals will provide a sample mean within 1 week of the population mean. So my margin of error is within 1 week. Okay. All right. So then I can figure my minimum sample mean and my maximum sample mean would just equal the population mean minus 1 and the population mean plus 1. So if I want to know the probability of getting a sample mean within 1 week of the population mean, I'm looking for sample means between 16.5 and 18.5. I hope that makes sense. And I want to know what the probability is that the population mean would be 17.5 and I would get some sample mean within that range. That's the whole point. Okay? All right, so now what is the probability that I will get a sample mean less than the maximum? And to do that, I'm just going to use the same function as in the last chapter, which is norm dist. Okay. And in this case, x will be 18.5, and the mean will be 17.5. And the standard deviation, make sure you use the sample standard deviation, is this, and true. Okay, that's the probability that I would get a sample mean of 18.5 or less given an assumed population mean of 17.5. Now I want to do the same thing for the minimum. So it's just the same thing, equals norm dist, and x would be 16.5, and the mean would be 17.5, and the standard deviation would be 0.5657, and true. And that tells me that there's actually a low probability that I would get a sample mean less than 16.5 if the population mean was 17.5. But what I want to know is, what's the probability that it's between 16.5 and 18.5? And to do that, same as last time, it's just the maximum minus the minimum. Again, I don't know why that's doing that, but it's C13. Okay, so that's B, wants to know what's the probability that I would get a sample mean between 16.5 and 17.5 if the population mean is in fact 17.5. And the probability is fairly high, it's 0.9229. Okay, now I can, if I look at the sample size and I just change this and I say, okay, what if the sample was 100? So right now, see the population mean here is 0.9229, but if the sample size was 100, the probability is much greater. So I have much more confidence. You understand? All right, so I'll change this back to 50. All right, now, C wants to know, well, what's the probability that I would, if the population mean is 17.5, what's the probability that I would get a sample mean within a half of week on either side? So I'll just change this margin of error to 0.5. And since I've already done the calculations, this shows me that I'd have a much smaller probability of 0.6232. So I'm just going to copy that down here, 0.6232. That's the answer to C. And I'm going to go back here and change this to 1. Okay? So that I have all my answers here without having to do the whole thing over again. So that's basically all there is to it. All the homework is pretty much like that. Again, what we're doing is we're assuming a population mean of 17.5, and we're testing to see how confident we are of that given a sample mean between 16.5 and 17.5. We have a high probability, okay, within a 1 week margin of error. We have a much lower probability within a half a week margin of error. Hope that makes sense to you. Good luck with your homework.